This is one of the interactive models we built to interpret linear equations. So how to interpret this type of linear equations and how it is representing in the real world. So here the water is discharged at the rate of 2 cubic feet per hour from the tank of volume 92 cubic feet. So the straight line represents the water level at a given time. So here this is x-axis represents the time discharge time as a t, and this is the water level. So now the water level is going to go down as t increases. As the t goes increases, this water W goes down. So now let's see that how it goes. The water level at a given time, if at the given, even initially it is 92. So when t equal to 0, this is 92, it's 0 comma 92. So now if I increase the time, so now time is 17. So when the time is x-axis, that is the t equal to 17, now the water level goes down 58. Similarly, the water level goes down all the way down to 0 when the t equal to this point. So now let's move this point. So now we are closer. So now move this point. Now water is 0 when it is 46. So when t equal to 0, the water is the t equal to 46, the water is 0. So how this represents these real world problems. So this from this model you can understand what each component represents in these equations or in this model. So now you have another you can interact with other parameters, like if you can increase the discharge. Now it's a discharge rate is 6, the 6 cubic feet. So now the line is getting steeper. So now this, as t increases, y decreases faster. So it's a deep. So now you can increase the water level or decrease the water level. So initial water level, now it is 100. So now if it is 67, 60, now you decrease the rate. So now 3. So now if you increase, if you position this coordinate as 20, so when t equal to 20, the W equal to 0, completely discharged. So this is the model, one of the important linear model. So now how this will help us to solve any problems in SAT. Let's take this problem, this actual problem. So a pool initially contains 1385 cubic feet of water, and pump begins emptying the water at a constant rate of 20 cubic feet per minute. Which are the following function best approximate the volume V in cubic feet of water in the pool t minutes after pumping begins? So this is exactly represents this model what we have seen. So now this is minus 20. Every unit of t, 20 cubic feet is discharged or emptied. So therefore, and option A is the answer. So interact this type of model, visit www.interactivesatmath.com.